Welcome back. We're looking at graphing inequalities by hand. And a lot of times with these inequalities, we're going to be reminded of our conic sections. So this is kind of a good review for our previous chapter. So the first thing we want to go over, if we are graphing an inequality, we want to recognize that it is an inequality. And we see that right away with the inequality symbol, x is less than. So the other thing, if we're looking at this, the first thing would be maybe to replace the inequality symbol with an equal sign so we can get a better view of what kind of curve are we actually graphing. So I have x equals y squared plus 4. And then a little bit of conic section recognition here. Remember, if only one of the variables is squared, we do have ourselves a parabola. And because the y variable is squared, we actually have ourselves a horizontal parabola. And it appears to be not in the form that we were dealing with the conic sections, but a little bit more from maybe our previous math courses. We do have kind of the form x equals a times y minus k squared plus h, the little shifting form, I should say. And that's going to remind us that we do have, depending on what the a is, what are we facing in terms of which way. So in our case, for our parabola, the a is equal to 1. See if I can write that in there. We do have a 1. So that's positive. So that kind of gives us a hint that our parabola is going to be opening up towards the positive side. So at least I kind of have an idea of what direction we are orientating ourselves. The other thing is we can recognize what our vertex is. So with the horizontal parabola, if we have a vertex, it's always in the form h comma k. So in our case, our vertex, if we're comparing this to this nice formula, our vertex is 4, and there's no y minus k, so it's assumed to be a 0, so our vertex is 4 comma 0. So that could be nice. The first thing we graph for ourselves is what the vertex would be. So I'll count 1, 2, 3, 4, and I've got my vertex. And if I'm trying to graph this further, I'm just going to note to myself, what am I really looking at? I do have a parabola that's going to be opening up towards the right. So keeping that in mind. So at this stage, what I might do for myself, if I want to get a more accurate graph, I want to find at least maybe two or three points on the parabola. Because it's not in the form where we would care about the focus or the directrix or the latus rectum, I might look at just using an XY chart to figure out finding more points on the parabola. So if you don't mind, I'll kind of take this off to the side. You know, whenever we do get lost with graphing, the XY chart does help us. We just have to remember that x is equal to y squared plus 4. So, you know, if the equation is solved for x, the first thing you probably would want to choose would be particular y values, if this helps you. Or you can decide, you know, where do I want to see this? So I'll kind of do a couple things for you just so that you understand. It's already solved for x. If I choose y values, I have to be careful because, well, I gotta make sure that we don't zoom out again. I want to be careful because I want to be clear. I'm obviously not going to pick y equals 0 because that's already where the vertex is. So we've already taken care of that. So we could pick y equals 1, maybe. So if that is the case, we can kind of see where our x value goes. So if we are doing that, I just kind of have to do a hand computation, excuse me. If y equals 1, x equals 1 squared plus 4, and that's going to leave us with 1 plus 4, which is 5. So we do have an ordered pair, that's 5 comma 1. And we do know, if we already understand where the vertex is, we kind of recycle our concepts, is that we do have an axis of symmetry. So the axis of symmetry in this case for a horizontal parabola is the x-axis, that's y equals 0. You don't really have to label it, but it gives us a hint that if you find something on the top of the axis of symmetry, you just count directly the same number of units to find the other point. So that's found by symmetry. That would mean that if we chose y equals -1, we would still get x equals 5. So the next one I will choose for myself, if I'm going with ones, I might as well choose 2. I'm just trying to pick really nice numbers. So if I choose y equals 2, that gives me x equals 2 squared plus 4, which will give me 4 plus 4, which is 8. So if I kind of recycle this back into my chart, I'm looking at 8, 2. So let's kind of write that in. So that's 4, 5, 6, 7, 8, and then up 2. So now we have our next point, and we can use symmetry, which is really cool, to find the other point. So if we have 2 units away, we also have 2 units away. So that my other point is 8, -2, just by symmetry. So that's what I want to make sure I have. So I'm really clear about what my parabola is doing. Oops, I didn't mean to delete that point. So now I have a great idea how wide to make it. It's super accurate. I always choose at least a few points to get me going. If I am going to graph it, the next thing I have to decide is, will I have a solid or dashed curve? And because we do have the less than symbol, there's no less than or equal to, we're going to make sure we're going to use a dashed curve for this. So we'll do our best to emphasize that it is a dashed curve and not a solid curve. So we do have the direction in which our parabola is facing. We have the nice boundary curve. Very last step, remember, this is an inequality we are looking at. We're going to have to figure out which way to shade. Now, sometimes you do a lot of these and you start to figure out what the pattern is, but the foolproof way of figuring out what direction you're going to shade or what side of the curve you're going to shade on is to pick a boundary point, or I shouldn't say boundary point, I should say a test point that's not on the boundary curve. So we don't want to pick the vertex. We don't want to pick any of, let me zoom that back in for a second. We don't want to pick any of these points that we chose because that would be located on the curve. I like to pick something that's far away from the curve. So my favorite point is 0, 0. But I don't have to choose that. If the curve goes through it, I can say like 0, 1 or anything like that. So I'm going to pick my test point. And in my case, I'm just picking something that the curve doesn't go through. It is 0, 0. And I will plug this into the original inequality. So the original inequality is 0 for x. 0 is less than, and that's a question. 0 is less than 0 squared plus 4. And then we're just trying to see, do we have a true or false statement? So let's simplify. We have 0. Okay, no problem there. Now 0 squared plus 4 is 4. So then you just have to ask yourself, is 0 less than 4? And you're saying, yeah, 0 is less than 4. So what we have for ourselves is a true statement. And whenever you have a true statement, you're going to shade the region that contains this test point. So I kind of marked it with an X, if you guys didn't notice that right there. There's my test point. And so I basically shade the entire region. I think I'll use my highlighter on this one. We'll do purple. And I guess if you don't have a highlighter, let's see if I can demonstrate what would I do if I had a pencil. You would probably see me kind of shade it with, I don't really have to go crazy on the coloring, unless that's something you want to do. But I like to use like a kind of hash lines to help me out. So I'm basically shading outside this parabola. So I'll help you out with that way. Now, if you have a highlighter and you want to make it pretty, have fun. Why not? So that is the graph of this particular inequality. One last thing I will point out, sometimes we don't pick the region that ends up being a true statement. I might want to just show you one more thing. If I were to choose a point that's in what the false region would be, that's the point that I'm not shading. So for instance, if I were to choose a point, let's say we're choosing a point right here, that's 10, 0. So if I were to choose that test point, 10, 0, I like 10s, I like zeros. And I plug this into the inequality, which is x is less than y squared plus 4. So if I choose x is 10, the question is it less than 0 squared plus 4? And then we kind of say, wait a second, let's simplify. 10 less than 4. We end up getting a false statement. So notice with the false statement, you're just making sure you go back to where this is located. And you're going to say, okay, well, we don't want to shade that region. So we're going to leave that entirely blank. So if you want to emphasize, I know I have a lot of markings, you can kind of show that, hey, that's the location where I would leave that blank. So it justifies no matter which point you pick, no matter what region you pick, just pay attention to whether you're getting a true or false statement so that you can know where to shade. So I hope this helps. We're going to move on to the next example. We'll see you then.